Hi everyone, this is Mr. Zhang, and today we'll be going with math homework for Class P. This is for session U18. For question number 1, it says that Nettie buys 600 roses at 40 cents each. Now she's able to sell 80% of them at $8.90 per dozen, but at the end of the day, she sells the rest for $3 a dozen. What profit does she make? So the keyword here is profit, and profit represents the total revenue, which is the money that you get, minus the total cost. So she didn't make the roses herself, she had to buy the roses. So specifically here, the total cost will be 600 roses, and the keyword here, each, with 40 cents each, means you have to multiply. So 600 times 40 cents. 40 cents you can rewrite as 2/5 of a dollar. So then when you do 60 and 5, and that 600 turns into 120, and 120 times 2 is $240. So right off the bat, it costs her $240 that she has to make up. Now she sells 80% of them, and of is the keyword there, and of means multiply. So 80% is 4/5. So she buys 600 roses, so she can sell 80% or 4/5 of the 600. So 605 cross cancels, and you got 120. And 120 times 4 is 480. Now, she sells them at $8.90 per dozen. So you have to figure out a dozen, and a dozen represents 12. So here, 12 roses, or 1 dozen, is equal to $8.90. And she sells 480 roses. So you have to multiply 12 times 40 to get 480. So for this proportion, the other side, you're going to have to multiply by 40 as well. So when you have 8.9, you can multiply by 4. And that's 356. And then you have to move the decimal point to the left once. But now since you're multiplying by 40, you'll have to move the decimal point back. So this will give you $356. So she already made some money, but for the rest of the roses, you don't want them to go bad. So she sells the rest, which is just 20% of the roses. And 20% of the roses is equal to 120. And that is going to be $3 a dozen. So 12 roses for the last set will cost $3. And she has 120. So that's going to be $30 extra. So all in all, you have $356 plus this 30. So the total revenue is going to be $386. And the total cost will be $240. So when you subtract, you get choice E, 146. So for this question, you have to remember or memorize that total revenue minus the total cost is equal to the profit. And then here the keywords are just each and percent, so so you'll have to multiply. Next one, number 2, while at Montoni's Pizza, you eat half a large pizza. When you arrive home, you eat half of the remaining pizza and put the rest in the fridge. At midnight, you eat 1/3 of the remainder. What fraction of pizza is left? So you start out with half, which means there's half left. But when you get home, you eat 1/2 of the remaining. So half of the remaining is going to be, well, just 1/4. So you eat half, and then you have half remaining, which is 1/2. Then here you eat 1/2 of 1/2, which is 1/4. So that means there's 1/4 left. And last but not least, after midnight, you eat 1/3 of the remainder. So you eat 1/3 of 1/4, which will give you 112. So that means there's 2/3 of the 1/4 left, and that's going to be 2/12 or 1/6. And that's choice A. So each time you see the word of, it means to multiply. Next, for number 3, a contractor agrees to pave a rectangular 80-foot by 140-foot parking lot for $1.25 per square foot and to fence in all 4 sides of the parking lot for $18.50 per foot. What's the total cost of this project? So when you pave the lot, that's going to be the area inside, and it's 80 by 140. So the area is length times width, so that will be 80 times 140. And when you do 14 times 8, that's equal to 112. And you have 2 zeros, so that will be 11,200 square feet. Now it costs $1.25 per square foot, so you have to multiply 112 times 1.25. The other way to do this is actually by dividing it by 4. And it just add it to itself, because you can take that 25 cents. So 112 divided by 4 is 28. So you'll have to do, when you multiply by 1.25, you really just multiply by 1, so 1,200 plus another 2,800. So when you add everything up, I have $14,000. Now that's just for the area. You also have to fence in the 4 sides, so that's the perimeter. So the perimeter is, the form for the perimeter is 2L plus 2W. So that's going to be 2 times 80 plus 2 times 140. And that's equal to 160 plus 280. And that is equal to 440 feet. So for this 440, you have to multiply by 18.5. So we do 18.5 times 44. That's 8140. So if they add 8140 to 14,000. That's 22,140, which is choice D. So here for number 3, you just use the formulas for the area and the perimeter, and then you just multiply it by the cost. Next, for number 4, the Scholar's Arithmetic, written by 1815 by Daniel Adams, includes the conversion table. How many more gallons are in 1 puncheon of beer than 1 puncheon of ale? So just have these units, and you just have to convert them. So you want gallons in 1 puncheon. So puncheon is here. So for 1 puncheon, that's equal to 2 barrels. And from barrels, you know that 1 barrel equals to kilograms. So you'll have to double that, which will be 4K. And then 1 kilogram is 2 fergans. So again, you multiply by that again. So 4 times 2 will be 8 firkins. So now we're at firkins. 1 firkin's 9, so you have to multiply by 9. That would be 72 gallons of beer. Now for the ale, everything's the same, but instead of multiplying by 9, you'll have to multiply this 8 by 8, because there's only 8 gallons of in 1 firkin of ale. So you have 8 firkins times 8 will be 64. And this is for ale. So when you subtract, it's going to be choice E, 872 minus 64. Next for number 5, you have 398 squared. Is that number 3998 squared, and then 39998 squared, etc., etc. So what's the sum of the digits of 399999998 squared? So if you look for the pattern, each time you add another 9, the digits keep increasing. And you want to add. So here you just want to find the pattern. So here you notice a couple of the digits are the same, specifically 1, 5, 8, and then 4 and 4. So 1, 5, 8 always stays the same. There's always a 1, 5, and an 8. And then there's always the 2 4s at the end. Now the 4s get further apart with the zeros, which doesn't change the sum of the digits. And the only thing you want to worry about are the 9s. So each time you add a 9, if you add a 9 to this square, you get a couple of extra 9s. So with 3 extra 9s, you have 3 extra 9s here. So when you want to square this, you have the 1, the 5, and the 8, and then the 4 and a whole bunch of zeros, 4. And in between are the 9s. Now, if you count how many extra 9s you have, because remember, with 1 9, you have 0 9s. In 1 9 with 398, you have 0 9s here. So you have 1, 2, 3, 4, 5, 6, 7 9s. So that means you'll have 7 9s here. So when you have 7 9s, that's 63. And you want to add the 1, 5, 8, 4, and 4. So this is 6. And 8, 4, and 4 is 16. So that's another 22. So 63 plus 22 is 85. So the answer is choice D when you just look for the pattern. Next for number 6, among the 42,500 men playing college basketball, about 1/5% will play major league, baseball, not basketball. What is 1/5% of 42,500? So 1/5 is 0.2, but this is a percent. So you have to move the decimal to the left 2 more places. That's going to be 0.002 or 2 over 1,000. So you'll have to multiply 42,500 times 2 over 1,000. And the 2 zeros will cancel out. So the 2 into 10 cancels to form 1 and 5. And then the 5 goes into 425. When you do 425 divided by 5, you get 85. That's choice A. Next, for number 7, you have this expression, and this is equal to. So here you have to be careful with distributing the -1 in front of the parentheses. So when you distribute the -1 inside parentheses, you'll have to flip the sign. So this becomes x minus y, and you have minus y and plus 2x. Then for the next one, you have this -1. You'll have to distribute it to the y minus x and the 2y minus x. Now, when you distribute -1 to y minus x, you flip the signs. So -1 times y minus x becomes -y plus x, because it's -1 times y, which is -y, and then -1 times -x, which becomes positive x. Then you have that -1 distributed to the second part, and this part's already negative, so it's already negative there. So you just turn it positive. You have -1 distributed to negative parentheses 2y minus x. Just turns into plus 2y minus x. So when you add everything up, you have 2y, minus y, minus y, and minus y. So that's 1 minus y left. And for the x's, you have x plus 2x, so that's 3x, 4x, and then minus x, that's 3x. So this is going to be 3x minus y, choice A. So here's a summary for this first page. Next, for number 8, before conference swim championships, Suzanne's best time for the 200-yard butterfly race was 2 minutes 23 seconds. In the conference championships, she won 10th place by swimming the 200-yard butterfly in 2 minutes 15 seconds. What percent decrease is that rounded to the nearest tenth of a percent? So percent decrease is a formula for percent change. It's new minus old divided by old times 100%. And this is 4% change. Now here you have to convert everything to the same unit, so seconds. So the new time was 2 minutes 15 seconds, which was 120 plus 15 or 135, minus the old time was 120 plus 23 or 143. 1 divided by 143. Now 135 minus 143 would be a negative number, which is normal because this is a percent decrease. So it should be negative in the numerator. This will be negative 8 over 143 times 100%. Now the numbers are pretty close, so you'll have to do some dividing. So 143 goes into 800. You can guess about 5 times. So you got 715 there. And then 143 goes to 850. You can guess about probably 6 times. That's 858, so it's actually a little bit less than 6. It's another 5. And then when you put another 0, this will be a pretty high number. So 0.55, you look at all the choices. When you round, should be choice B. It's about 5.6. You have 5.5 as the answer. So it's probably like 5.59. So you have 5.6 is the closest. Next, for number 9, the area of the 48 contiguous states can be approximated by 3,000 miles by a 1,000-mile rectangle. The population of the 48 states is about 265 million. Using this data, which is following the closest population density of the 48 states in people per square mile. So you take number of people, 265 million, and you here per means divide. So you just divide by the square mile. So it's a rectangle, so area is length times width, which is 3,000 times 1,000. Now you can just cross out the zeros as a shortcut. So it just becomes 265 divided by 3. And we have 265 divided by 3. It's going to be about 80-something, and that's choice C, which is the closest. It's about 88. Next, for number 10, suppose 800 soldiers were placed in a garrison, and their provisions were computed sufficient for 2 months. How many soldiers must depart so that provisions may serve the garrison for 5 months? So here you have 800 soldiers, and you can have enough food for 2 months. So food will be enough for 800 people, 2 months. Well, here you can see that food and people will be inversely related. Because the more people you have, the more food they'll eat. So then therefore, the less it will and last. So these are inversely related. That means for example, if you take this to 1 month by doing 2 divided by 1, that will only be for, if you double this, which will be 1,600 people. So if you double the number of people, the food supply will last half as much, because this is an inverse operation. So if you multiply by 2 on the left, you have to divide by 2 on the right. Now you want to go to 5 months. So if you multiply by 5, you'll want to divide by 5. And 1,600 divided by 5 is about 500, or it should be less than 500, and it's going to be choice D, 480. So this is an inverse relationship here. Okay, the more people you have, the more food you need. So the food will last a shorter period of time. So number of people is inverse with time food will last. Okay, next for number 11, for a clock with an hour hand and a minute hand, how fast is the hour hand rotating in degrees per minute? So the hour hand, as you know, goes around 1 hour every hour. Now, in order to go around 1 hour, that's actually just 1/12 of the clock. Because if you go around the clock, it's 12 hours, and that's 360 degrees. So 1 hour will only be, if you divide by 12, that will be 30 degrees. So because the hour hand is moving 30 degrees per hour, you know that 1 hour is equal to 60 minutes. And if that's equal to 30 degrees, to figure out the minute, you'll have to divide by 60. So in each minute, you'll have 30 divided by 60, or 1/2 a degree. That's choice A. Next for number 12, in 1973, the horse Secretariat won the Belmont Stakes in 2 minutes, 24 seconds by running the 1.5 miles in the fastest time ever. What's the average speed per mile? So here you have to convert again. You want miles per hour, so you have 1.5 miles. And here you have 2 minutes, 24 seconds. So let's convert everything into seconds first. That's going to be 120 plus 24, or 144 seconds. Now here, to figure out miles per hour, you know that in 1 hour you have 60 minutes, and in each minute you have 60 seconds, so that will be 3,600 seconds. So you put 3,600 seconds underneath the 144 seconds, and this would be X miles, and this is your proportion. So you have 1.5 times 3,600 is equal to 144x, and you have to divide by 144. And when you have 3,600 and 144, you have a common factor of 12. So you have 1.5 times 300 divided by 12. So 1.5. Oh, and 300 you can cross cancel again with 12 because they have a common factor of 6. That'll be 50. So 1.5 times 50 will be that's just cross cancel again. So it's 1.5 times 25, and finally that's choice D. So it does become mental math once you cross simplify. Next for number 13, the only two-digit number that is both a perfect square and a perfect cube is 64. What's the sum of the digits of the only three-digit number that's both a perfect cube and a perfect square? So the reason why 64 is a perfect cube and a perfect square is because you have 4 times 4 times 4, and you have 8 times 8. So in order to find a three-digit number that can be both a perfect square and a perfect cube, you'll just have to keep increasing the digits. So you can go 5 times 5 times 5, which is 125, and 6 times 6 times 6 is 36 times 6 is 216. Which is not a perfect square. Then you have 7 times 7 times 7, which doesn't work. So 7, 7, 7 is odd, and you can't really break that down anymore. Next up is 8 times 8 times 8, and each of the 8s is 2 cubed. So you have really just 9 2s, and that's not a perfect square because you have 9 2s. So then you want to try 9, 9, and 9. And you can see that when you have 9, 9, and 9, that's the same as 27 times 27. So 9 times 9 times 9 is probably going to be it. And that's 81 times 9, which is 729. So if you add up the digits in 729, you get choice D, 18. Next, for number 14, in arithmetic sequence, the third term is 1227 and the ninth term is 2001. What's the fifth term of the sequence? So if an arithmetic sequence, that means that you have to add a common difference to get to the next term. So you can actually set up either an equation. So a of n will be equal to first term, which is a, plus n minus 1 times d, this common difference. So it's essentially it has to be a linear relationship. Now you can also just write out this the third term, fourth, fifth, sixth, seventh, so 4, 5, 6, 7, 8, and the ninth term is 2001. So when you count how many jumps you have 1, 2, 3, 4, 5, 6 jumps. And in these 6 jumps, you have to increase the sum by doing the difference. For this difference of 774. And when you do 774 divided by 6, get 129. So 6 jumps represents 129. Or just 129 in each of the jumps, I should say. So that's the common difference. So that means that to get the fifth term, you have to add 129 2 times. So 129 times 2 is 258, and 258 plus 1227 is 1485, choice D. You can also set up this formula, and you can do elimination by doing 120 or 1227 is equal to A plus, here n is 3, so you'll have to add the common difference 2 times. So it'll be A plus 2D. Because again, you don't count the first term. You don't know what the first term is, so you just call it A. To get to the third term, you have to add D, this common difference, 2 times, because there are 2 jumps. And for the ninth term, you have 2001 1 is equal to A plus, here for the ninth term, you have to add D 8 times. And from here, you can subtract and solve. So when you subtract these two equations by elimination, the first term A cancels out. You have 6 times the common difference, equal to the same difference of 774. You get that D is equal to 129, and you can just substitute back in to solve. Next, for number 15, each side of the square is trisected. What fraction of the square is shaded? So trisected means cut into 3 equal pieces. So you make a tic-tac-toe board, and everything is super even. So to figure out the shaded portions, you have each of these 9 pieces are cut. You can just cut them in half. So if there are 18 pieces total, or the whole, and the part is the shaded, which you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it's 12 over 18, or 2/3, choice B. So here the keyword is trisected, which means cut into 3 equal pieces. And here is the summary for this page. Next, for number 16, when 22 divided by 5, the whole number remainder is 2. Which of the following division problem has the smallest whole number remainder? So here, when you want to do division, we have 22 divided by 5. You know that it is 4, remainder 2. So you want to see which one has the smallest possible remainder. So when you go through all the choices, you'll just have to guess and check. So for choice A, when you have 2487 divided by 42, that's going to be 59 point something. So if you do 59 times 42, that's 2478. And when you subtract 2478 minus 2487 from 2487, you get a remainder of 9. So then for choice B, you have 1533 divided by 20. That's going to be 76 point something. So you'll have to do 76 times 20, which is 1520, and subtract that from 1533, and that's going to give you a difference of 13. So next up, 1677 divided by 56 is 29, and 29 times 56 is 1642. So that's going to have a remainder of 35. Next, for choice D, you have 8175 divided by 120. That's 68. And 68 times 120 is 8160. That's a remainder of 15. And finally, 1911 divided by 35 is 54. And 54 times 35 is 1890. So when you subtract, that's going to be a remainder of 21. So here we see that choice A has the smallest remainder of just 9. For this question, you just have to divide, guess, and check. Next, for number 17, Marge played varsity basketball all 4 years of high school. Each year, she increased her average points per game by 20% over the preceding year. Now, she scored 18 points per game as a junior. What was the difference in points per game between her senior year average and her freshman year average? So you have 4 years of basketball, and she scored 18 points as a junior. And now, each time you increase her average by 20%. So when you increase by 20%, you're really multiplying by 1.2, because you have to do the 20% added to the original, which is 100%. So 18 times 1.2 will be 21.6. And now, to go backwards, you'll have to divide by this number. So when you go backwards, you have, for example, this could be x. X times 1.2 will give you 18. So to go backwards, you have to divide both sides by 1.2. So when you have 18 divided by 1.2, that's equal to 15. And you'll have to divide by 1.2 again. You get 12.5. So now you want to see the points difference between freshman year, which is 12.5, and 21.6. When we subtract, that's a difference of 9.1, which is choice B. Next for number 18, if m is a whole number, which one of these 5 numbers could be equal to 6m plus 1? So you want to subtract 1 from all the choices, because we're working backwards. And one of these numbers is actually a multiple of 6, because this would be equal to 6m. Now the divisibility rule for the 6 times table is that it has to be divisible by 2 and 3. So it has to be even, so you eliminate choice C and A because they're both odd. And now the sum of the digits need to be divisible by 3. So if you add 5 plus 1 plus 2, that's equal to 8. That's not divisible by 3 in choice B. And for choice D, 5 plus 4 plus 1 is 10, which is not a multiple of 3. But if you have 5 plus 1 plus 6, that's equal to 12, and 12 is divisible by 3. So the answer is going to be choice E. 516 is a multiple of 6, and then you add 1 to it to get 517. Next for number 19, given that 0.5 is less than or equal to x is less than or equal to 2, and negative 8 less than or equal to y is less than or equal to negative 4, what is the smallest possible value of x plus y divided by x? So the smallest possible value means to minimize. Now if you look at the choices, they're all, almost all of them are negative. And when you have a negative fraction, this means that one of these, either the numerator or the denominator, has to be positive, and then the other one has to be negative. So the signs are going to be a little different. Now, if you want the smallest possible value, and since this is a negative number, you want a large negative numerator and a small positive denominator. So here, the smallest positive denominator could be 1, because you're just dividing by 1, which means nothing would happen. Now, if x is equal to 1, y could be equal to a large negative numerator, which could be negative 8. So when you do guess and check, you'll have 1 minus 8 divided by 1, and that's equal to negative 7. So you have negative 7. Now I want to see if you can turn this into a smaller number. So let's make the denominator even smaller than 1. Let's make it equal to 0.5. So that will give you 0.5 minus 8 divided by 0.5. And 0.5 minus 8 is negative 7.5. And we divide it by 0.5, that's going to be equal to negative 15. Because that's just 75 divided by 5, and that's choice B. And here you can't make the denominator any smaller. If we try to make the denominator bigger, it's going to actually minimize and make this entire fraction a little smaller. So the answer is choice B. Next for number 20, triangle ABC is an isosceles triangle with AB equals to AC. And BD is a bisector of angle ABC. And now AE is perpendicular to BD. So just say right angle there. Now if angle C is equal to 40 degrees, what's the measure of angle EAD? Well, since you have an isosceles triangle, that means that 2 sides are equal, and the opposite angles are equal as well. So if angle C is equal to 40 degrees, so is angle ABC. And because that got bisected, which means it got cut in half, Each of these will be equal to half of 40 or 20 degrees. So once you know that each side is equal to 20 degrees, triangle ABE is a right triangle because you know that triangle AED is a right angle, they're perpendicular. So this is 90 degrees, and a triangle adds up to 180 degrees. So you have 90 and 20, which is 110, and when you subtract that from 180, you get 70. So triangle BAE is 70 degrees. Now you're almost there. You can figure out the other angle and on the other side. So for the entire triangle, it's also equal to 180 degrees. And you have 40 and 40 as the base. So that's already 80 degrees. That means that the top has to be 100. If you know that this piece is 70, the other piece has to be 30. And this gives you a 30, 60, 90 special right triangle. So the measure of angle EAD is this 30 degrees. Because you know that the top has to be 100 degrees. And you already have that 70, so the remainder must be 30. Next for number 21, if 6 men build a wall 20 feet long, 6 feet high, and 4 feet wide in 16 days, in what time will 24 men build one 200 feet long, 8 feet high, 6 foot wide? So here, you have to figure out the volume of this wall is 20 by 6 by 4. And that's, this is 120 times 4, or 480 cubic feet. And this is in 16 days, which is a unit of time. And this is for 6 men. So a couple things are directly proportional. Some things are inversely proportional here. To figure out the size, for example, you want to turn this 480 into this volume, which is 200 by 8 by 6, which is 200 times 48, which is 900 or 9600. So to go from 9600 from 480, you have to multiply it by 20. So if you have this wall that is 20 times bigger, well then that's going to take 20 times longer if you have 6 men. So you can only change 2 variables at a time. Size and time are directly proportional. Because the bigger the wall, the more time it'll take. So I also have to multiply by 20 here. That'll be 320 days for 6 men. Now you have more than 6 men because you have 24 men. This time, the more people you have, if you multiply by 4, it'll actually take less time because time and people, they're inversely proportional. So the more people you have working on the same project, it'll take you less time. So if you multiply the men by 4, that'll be 24 men. That will take you 4 times less. So you'll have to divide by 4. 320 divided by 4 is 80 days. And that's choice D. So be careful here in terms of the size of the wall and time are direct, but there's an inverse relationship between the time and number of people working. The more people you have working, the less time it takes. So you can only change 2 variables at a time. So if it's direct, multiply both sides by the same number. If it's inverse, you multiply one side and then you divide the other side because it's an inverse relationship. Okay, and here is the summary for this page. Next for number 22, in trapezoid ABCD, AB is equal to 88 centimeters and BC is equal to CD is equal to DA. If the perimeter of the trapezoid is 208 centimeters, what's the area in square centimeters of the trapezoid? You have a trapezoid that looks like this, and you know that A to B is equal to 88, whereas the other 3 sides are equal to one another. So you'll have to draw your trapezoid here. And you know that the perimeter is equal to 208. So you know that 88 plus the missing sides, which are all the same, you can call them x. 88 plus 3x would be equal to 208. So if you subtract 88 from both sides, you get that the 3x has to be equal to 120. So then if you divide by 3, you get that each of the sides are going to be 40. So from here, you can use this to figure out the area of the trapezoid. So for the trapezoid, you can split this up into 3 shapes. Now the top piece is 40. The bottom piece is also going to be 40. And 88 minus 40 is 48. And you have to do 48 divided by 2 to figure out that each of the remaining pieces are 24. Now from these triangles on the side, these are going to be right triangles because you split up this trapezoid into a rectangle and 2 triangles on the side with side lengths of 24 and 40. So from here, you can divide everything by 3 to figure out that this is one of the Pythagorean triplets. And a Pythagorean triplet is just 3 whole numbers that satisfy Pythagorean theorem, which is a squared plus b squared is equal to c squared. Specifically, this is a 3, 4, 5 if you multiply everything by 8. So this is a 24, 32, 40 right triangle. And the missing piece is going to be this 32. So that means the height here is equal to 32. So now you have all the information necessary to solve for the area of this trapezoid. The formula for the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So that's going to be 1/2. Base 1 is 40. Base 2 is 88. And the height you just found to be 32. So you can take the 1/2 of the 32 to cancel that out to get 16. And then 40 plus 88 is 128. So you have to do 128 times 16. And when you do the first digit, 8 times 6 is 48. So you know that the ones place has to be an 8. So the answer has to be choice C. Eventually, when you multiply through, you'll get 48. Next, for number 23, the sum of 5 consecutive odd numbers is 5x plus 20. If x represents the smallest of the 5 numbers, what's the largest of the 5? So because you have 5 consecutive odd numbers, consecutive means that the numbers are one after the other. So the smallest number you can call x. Now, because they're odd, to get to the next odd number, you'll have to add 2. Then you have to add 2 again, so it'll be x plus 4, then x plus 6, and finally x plus 8. So here, if you add everything up, that's going to be 5x plus 20. So if you were to add up these numbers, you had to combine like terms. The x's, you have 5 of them, and you have to add 2, 4, 6, and 8. So that's going to be 5x plus 20. Now, to figure out the largest of the 5, you have x, which is the smallest. And the largest will be right here, x plus 8. And everything does add up to 5x plus 20, so everything does check out. Next, for number 24. Astronomers detect a large planet circling a star 7 times 10 to the 13 miles from Earth. If the astronomer on Earth sends a signal that travels at 186,000 miles per second to the planet, how many years will it take to reach for that signal to reach the planet? So it travels 186,000 miles per second. And you know that in 1 minute, that's equal to 60 seconds. So here, since you have 186,000 miles in 1 second, and you have the distance in miles, you have your rate, which is here. To figure out the time, you can use this formula D equals R times T, or T is equal to distance divided by rate. So you want to make sure you put everything into seconds. So when you have 7 times 10 to the 13th power, that's the distance, and that's in miles. You want to divide this by the rate, which is 186,000 miles per hour. Miles per second. So when you divide this, the miles will cancel out, and the denominator of the denominator will turn into the numerator. So here, this would be 7 times 10 to the 13th divided by 186,000 seconds. Now, to go from seconds to minutes, you'll have to divide by 60, because 1 minute is equal to 60 seconds to cross out the seconds. And you have to keep doing that until you get years. Then when you multiply 60 minutes, that's 1 hour. To cross out the minutes, then you have 24 hours, that's 1 day. And in 1 year, you have 365 days. So days will cancel out. So eventually your numbers, when you are multiplying these units, you'll have 7 times 10 to the 13th. And you'll be dividing by 186,000 times 60, 60, 24, and 365. So definitely need a calculator for this part. But you can also estimate here by just crossing out some of the zeros. So you have 1, 2, 3, 4, 5 zeros to cancel out. So then this 13 will just become 10 to the 8th. So it's really 700 million divided by 186 times 6 times 6 times 24 times 365. So you could just estimate here, or you can plug it into a calculator. And when you divide by 186, and then keep dividing by 6, divided by 6, divided by 24, and then finally divided by 365, about 11.9. And that's going to be choice B, 12, which is the closest to that number. So you just have to do a lot of conversions here. And D equals RT. Next to number 25, in quadrilateral ABCD, angle A is 32 degrees larger than angle B, and angle C is twice the measure of angle A. And angle D is 22 degrees larger than angle A. What's the sum of the measures of angles B and C? So you know it's a quadrilateral, so it has to add up to 360 degrees. So you just draw your quadrilateral. And A is 32 larger than B, and C is twice the measure of angle A. So you start with B, let's call it B. A is 32 degrees larger, so that's B plus 32. And C is twice that. So when you have B plus 32, and you double it, you'll have to distribute, which will give you 2B plus 64. And that's for angle C. And then angle D is 22 degrees larger than A, which will be B plus 32, which is angle A, plus another 22. So that's going to end up being B plus 54. So now you have everything in terms of B. So 360 degrees is going to be B plus 32 plus B plus 54 plus 2B plus 64. So when you combine like terms, you have 5B and you have 32, 54, and 64 to add. And that's 5B plus 150 is equal to 360. So you subtract 150 from both sides. You get 210 is equal to 5B, and you can divide by 5. And you get that B is equal to 42. Now, once you know B is equal to 42, you want to measure of angle B and C. So B is 42, C is 2B plus 64. So 2 times 42 plus 64 is going to be 84 plus 64, or 148. So you have to do 148, which is angle C, plus measure of angle B, which is 42. And that's going to be choice D, 190. Next, for number 26, the veterinarian buys 40 meters of fence to build 4 pens along the back of a kennel building. The 40 meters of fence are used for 3 exterior fences as well as the 3 interior dividers. The vet lets D equal to be 10. What's the total area in square meters enclosed by the 4 pens? So you only have 40 meters of the fence to build. So if you make these shapes, these dividers, these squares, this has to be 10 meters wide, and that's split into 1, 2, 3, 4 pieces. So 10 divided by 4 will be 2.5. Now, once you have 40 minus this 10 that you use, you have 30 left, and the 30 will be for the 5 vertical walls. So 30 divided by 5 would be equal to 6. So each of these pens will be 6 by 2.5. Now, to figure out the area by all 4 pens, you have the height of 6 and a base of 10. So the area is going to be base times height, or 6 times 10, which will be 60. Choice A. Next, for number 27, a fair tetrahedral die has 4 faces and 4 vertices, so corners. Each vertex is numbered, and each vertex is equally likely to land up. And now you have 2 such die. On die number 1, the vertices are labeled 1, 2, 3, 4. On die 2, the vertices are labeled 2, 3, 4, 5. When these 2 dice are rolled, the probability that the sum of the 2 up vertices is 7 is, so you want to have, the key word here is probability. That's just a chance. You can express it as part over whole. So you really have just 2 dice. So roll 1 and roll 2. So for roll number 1, you can have 4 numbers. Roll 2, you can also have 4 numbers. So if you multiply them together using the counting principle, you have 16 choices. So you can have 1, 2, 3, 4, and then each of these will branch out 4 times. And for each of these, it will be 2, 3, 4, 5. So you want to find all the chances that add up to 7. So you have, if you roll 1, there's no 7 in here, so you can cross it out. If you roll 2, you can have 2, 5. But if you roll 3, you can have 3, 4. And then if you have 4, you can have 4 and 3. So 4 first and 3 versus 3 first and then 4. These are separate branches of this tree because that means you're twice as likely to roll a 3 and a 4. So you have to count both of them. So that would be 3 branches out of a total of 16. And that's choice C. So it's 3 ways to get 7. And here's the summary for this page. Next, for number 28, the line 2x plus 5y is equal to 20 is a reflector of the x-axis. The equation of a new line is, so when you have an equation of a line, you really want to get this into slope-intercept form. Right now it's in standard form, and you want to make it into slope-intercept form, which is y equals mx plus b. So how to get y by itself. So you subtract 2x from both sides. So that will give you 5y is equal to negative 2x plus 20. Then you divide by 5. And you get y is equal to negative 2/5 of x plus 20 divided by 5, or 4. So you split the 5 into both of these sums in the numerator. So you have this equation. You have a negative slope. And you have a positive y-intercept of 0, 4. Now, when you flip this over the x-axis is here. This is your mirror, and this would go this way. So now your x-intercept will now be 0, negative 4, and then your slope will actually be swapped as well. So we have to find the slope of this new line. It's not just a negation, because, well, actually here, when you have a slope of negative 2/5, you have to negate it, and this will turn, instead of going down 2 and a right 5, you'll have to go up 2 and then over 5. So this slope will have a slope of positive 2/5. So it is a negation where you have the slope of positive 2/5, and this y-intercept is 0, negative 4. And that's all the information you need to make the equation of this new line. This would be y equals 2/5 of x minus 4. Now, you don't see that as one of the choices because you have to turn this into standard form. And to do that, you get rid of the denominators and move the x and y's to one side. So you multiply both sides by 5. You get 5y is equal to, when you distribute, you get 2x minus 20. And from here, you can subtract 2x from both sides. You get negative 2x plus 5y is equal to negative 20. And you want this one to be positive because I don't see this choice as one of the choices here. So to turn the 20 positive, you have to multiply both sides by negative 1, which will give you 2x minus 5y is equal to positive 20. You flip the signs. You multiply by negative 1 on both sides. The signs flip. And that we see as choice A. So when you reflect over the y-axis, you negate the slope, and then you also have to negate the y-intercept. Next, for number 29, A, B, and C each can be any digit 0 to 9, possibly the same. The 7-digit whole number, 20ABC01, is a perfect square. What is the middle digit B? So for this question, you have to look at this digit and just kind of look through and see some of the patterns. So because it's a perfect square and the units place is 1, you know that this number, when you square it, has to end in 1 or 9, because when you have any number like 1 squared, 11 squared, the ones place is always 1, and when you have 9 squared, it'll always end in 1 as well. So that really does restrict your choices. And then the other thing that you have to do is you know that this is 7 digits. So when you have 7 digits, it's going to be somewhere in the thousands, because 1,000 times 1,000 will be 1 followed by 6 zeros, so that's 7 digits. And now the first digit is a 2. So if you try 1,500 times 1,500, that's 225, followed by 4 zeros. So you know that it has to be between 1,000 and 1,500. So you would start counting down from 1,500. That's your best bet, because 225 is close to 20. But remember, the ones place has to be 1s or 9s. So you'll count down with 14.99 and then 14.91. Then you try 14.89, 14.81, 14.79, and 14.71, etc., etc. And from here, you can actually use benchmark numbers to try to get your range within some distance. So if you try from the 1400s, you would try 1401 and 1409 first. And you try 1401 times 1401 on a calculator, that's 1962801. So that's a little too small. You can also try 1451, that's just something in the middle. And that will give you really close. That would be 1451 squared is 2105401. So you're really close there. If you actually try 1449 times 1449, you get exactly that would be your answer. You will get 2099601. So the middle digit is a 9, choice E. So for this question, you just have to guess and check with the calculator. If you don't have a calculator, you would do this question last. Skip this, come back to it later if you find yourself without some extra time. All right, next for number 30. Marissa tosses her spare pennies, nickels, and dimes into a jar. When she counts her coins, she finds that she has 10 more nickels than pennies and 3 times as many dimes as nickels. She has P pennies, which expression represents the total value in dollars of her collection. So she has P pennies, and she has 10 more nickels than pennies. So 10 more nickels than pennies means you'll have to do P plus 10, and that would be 4 nickels. And then finally, she has 3 times as many dimes as nickels. So you have to take P plus 10 and multiply by 3 in parentheses. And this will be 4 dimes. So you have to put everything in terms of P, because a penny is 1 cent. So you have to multiply this P by 0.1 to have 0.1 P. You want everything in dollars, so that's why you have to turn this into a decimal. A nickel is worth 0.05. So when you multiply 0.05 times P plus 10 and distribute, you have 0.01 P, 0.05 P plus 0.05 times 10. So that's 0.5. And finally, a dime is 10 cents, so that's 0.1. So to multiply this 3 times 0.1, which will give you 0.3 times P plus 10. And when you distribute, you have 0.3 P plus 0.3 times 10, or 3. So you add everything up, you have 3.5 plus, this is really 30 plus 5 plus 1, or 0.36 P. And that's choice A. Next for number 31, by inserting exactly 1 pair of parentheses into this expression, how many of the following 5 numbers can be produced? So you want to put parentheses somewhere to try to eliminate all the choices. So if you put parentheses in the first two, 30 divided by 2, that's just 15. And then you want to add 3 times 2, which is 6, and that's 21. So you made 21. So you erase that pair, then you put parentheses somewhere else. If you put parentheses around those 2, or those 3 numbers, you have to do 30 divided by 2, which is 15. Then add 3, that will become 18 times 2. That's going to be 36. So I made 36, you can cross that out. You can also cross out choice 1, choice A. Then if you put parentheses there, of course that doesn't do anything. So the next part would be with this 2. So this would be 30 divided by 5 times 2. So 30 divided by 5 is 6, and times 2 is equal to 12. So you get 12, and choice B is wrong because you have 3 other numbers. So then you erase that. And then you want to try this piece. So you would do 3 times 2 first inside the parentheses. So that's 6 plus 2 is 8. You'll have 30 divided by 8, and that's going to be this would be remainder 6, or 3 and 6/8, or 3 and 3/4. So that's 0.75. So that's 3.75. So you cross that out. And then, so you're done with the 2's. Now, when you try to put this here, you get 30 divided by 2, which is 15, plus the 6 again. This you just get back 21. And you're done with the parentheses. You can't put parentheses anywhere else. So you only get 4 out of these 5 numbers, and that's choice D. Next, for number 32, to construct a pyramid from a 24 by 24 square piece of construction paper, Valerie cuts along the 8 bold segments to form an 8 by 8 square, PQRS, as the base of the pyramid. She then folds A, B, C, and D up to the vertex. What's the height of the pyramid? So this is a 24 by 24 square piece of construction paper, and she cuts along this to form an 8 by 8 square. So if you just cut across for the, kind of like the diameter of this, you have this piece in the middle, which is 8, and the entire piece is 24. So 24 minus 8 is 12, 24 minus 8 is 16. So then the remaining pieces have to be 8, or 16 divided by 2. So the height of this pyramid, you actually have to do, it's not choice E. When you have this pyramid and you fold it up, you have to do the vertical height. So this piece, D and B, would be joined up here. And the center is actually on the bottom. You have the right side, or the entire piece would be 8. And this side would be 4. The hypotenuse here would be this length. So this is called the slant height. So the slant height would be equal to 8. So you have a 4 and 8. And you want to figure out the missing height here. You can use Pythagorean theorem to figure this out, or this is actually one of your special right triangles. It's your 30, 60, 90 special right triangle, where you have sides of x, 2x, and x root 3. Because you have the 4 and the 8, you know that x is equal to 4, the 2x would be 8, and the height would be equal to 4 root 3. And here you have to unsimplify 4 root 3. 4 is really the square root of 16, and we have the square root of 16 times the square root of 3. That's the square root of 16 times 3, all underneath the square root, or the square root of 48. And that's choice C. So you have to be careful. This 8 here is actually called the slant height of this pyramid. So if you draw this in 3D, the slant height of 8 would actually go from the top of the pyramid down to the middle of one of the edges. And this piece is the 8. So you need to find the height down to the middle of this pyramid, which will be, in this case, 4 root 3, or the square root of 48. Okay, and here is the summary for this page. Okay, next for number 33, 1/2 of a fair circular spinner is divided into 6 congruent sectors, and these sectors are labeled 1 through 6. The other half is divided into 3 congruent sectors, and these sectors are labeled 7, 8, and 9. If the spinner is spun once, what's the probability that the number is odd? So here you don't have an equal spinner because you have one side is 1 to 6, the other side is just 3 numbers. So you have to cut each of these in half. And now you have a fair spinner. If you want the odd for just part over whole, So you want to count the odds, and you have 2 7s and 2 9s. So that's going to be 1, 2, 3, 4, 5, 6, and 7. So that's 7 odd pieces over the total, which will be 12. So that's choice C. You split the right side in half, so you have 12 equal sectors. Now next for number 24, if the fair spinner is spun 3 times, what's the probability that the sum of these numbers is odd? So when you're spinning this spinner 3 times, you just have to use the probabilities that we have from before. So the probability for odd is 7 out of 12. For even will be the remainder, which is 5 out of 12. And when you're adding 3 numbers, the only ways to get odd would be odd plus odd plus odd, because odd plus odd is even plus odd will be odd again. Or if you have 2 even numbers and you add an odd to that. So it'll be even plus odd, or even plus odd plus even, or odd plus even plus even. So when you spin the spinner first, again, an even plus an odd will be different from an odd number first plus even, and then an even number third, because you have 2 additional opportunities to get an odd sum. So all you have to do is just multiply each of these multiple times, because each of these would be the counting principle. So for odd, that's 7 out of 12 times 7 out of 12 times 7 out of 12. And you'll add this probability to even, odd, which is 5 out of 12 times 5 out of 12 times 7 out of 12. For even, odd, even, the chance of getting a first even number is 5 out of 12. And getting odd in the middle is 7 out of 12. And then getting an even last is 5 out of 12. And finally, for odd, even, the chance of getting an odd number first is 7 out of 12. And then for even second is 5 out of 12, and even third is also 5 out of 12. Now, any one of these can give you an odd sum. So you want to add these individual probabilities together, because you want a sum that is odd. So any one of these 4 scenarios will give you odd. So that means you'll have to use a calculator and add everything together. If you add everything together, that should give you, in the numerator, you'll have 868. And in the denominator, you have 12 times 12 times 12, which is 12 cubed. And when you simplify this, you should get choice C, 217 over 432. You can also turn this into a decimal in your calculator. Next to number 35, when 10 raised to the 20th power minus 5 is squared, is calculated, the sum of its digits is. So we have 10 raised to the 20th power. You just have 1 with a whole bunch of zeros. And when you subtract 5, you still have the 1. But all those zeros would then turn into 9s. So you'll have 9, a whole bunch of 9s, and then a 5, and you have to square this. You want to calculate the sum of its digits. So of course, even if you have a calculator, this number can't possibly fit. So you want to look for a pattern. Well, you can model this problem with smaller numbers. This exponent of 20 is really annoying, so let's model it using smaller numbers. Let's try 10 squared minus 5. So this would be 100 minus 5, or 95 squared. And when you have 95 squared, on your calculator, that would be 9,025. And then you want to try 10 cubed minus 5 squared. To see if there's a pattern, that is 1,000 minus 5, or 995 squared. And we square 995. That's 990025. And then let's try 10 to the 4th power minus 5 squared. That would be 10,000 minus 5, or 9995 squared. And when you do that, you get 999000025. So you can see the pattern here. You have more 9s and 0s, and then you also have 25 at the end. So when you have 10 raised to the 20th power squared, you just want to look for a pattern for the exponent. So with 2 in the exponent, you have just 1 9 and 1 0. But with 3 as the exponent, you have 2 9s and 2 0s. With 4 as the exponent, you have 3 9s, and 3 0s. So when you have 10 raised to the 20th power, that would be 19 9s, so you have 19 of these 9s, followed by 19 zeros, and then 25. So when you have 19 9s, that would be 19 times 9. The zeros don't contribute anything to the sum, and you have that 2 and a 5, which is 7. So you have 171 plus 7, and that's how you get 178. So you model this problem using smaller numbers, and there is a pattern. Next, for number 36, the date of the second Thursday of the month is a prime number. Of the following 3 dates, 23rd, 28th, 30th, the last Sunday of the month could be. So the second Thursday means that you want to see how many could actually work. So, for example, you can have the first day start on a Sunday, and you have a range of 7 numbers to choose from, because you want to see if they're going to be prime. Well, it has to be a prime number. So when you add 7, that would be 12. So that's not prime, so that doesn't work. So you just shift everything over. And when you add 7 to that Thursday, that would be 11. And 11 is prime, so this is definitely possible. You want to see the last Sunday. So the Sunday will be the 7th. Then you have the 14th, 21st, 28th. So the 28th could be the last Sunday, so 2 could be true. So you eliminate choice A, eliminate choice B, because it must have a 2 in it. So it would be the 28th if the Monday is the 1st. So you erase this calendar, and then you just draw another calendar. You start with Tuesday as the first. Add 7 to the Thursday, that would be 10, which is not a prime number, so you skip that. Then you try Wednesday to the first. Add 7 to the Thursday, that would be 9. That also doesn't work. And you can also make Thursday the 1st. That would mean the next Thursday would be the 8th, which is not prime. So Friday could also be the 1st. If that's the case, next Friday would be the 8th. And then you have to add another 7. This Thursday would be the 14th. So that's not a prime number. And then the last one is if Saturday is the 1st. This Thursday would be the 6th. And then if you add 7 to that, that would be 13. So 13 is a prime number. So this would work as the second Thursday if Saturday is the 1st. And then for the Sundays, just keep adding 7. The 30th could also work as Roman numeral number 3. So that would be the Saturday is the 1st. Okay, and then the last situation is if this was a February, the 30th, not all months have a 30th in it, so some months might have a 23 in it. So the 23rd could also be the last Saturday if Saturday is the 1st of February. Remember, not all months have 30 or 31 days. So the 23rd can actually be the last Sunday of the month. Okay, next for number 37. Triangle ABC is a right isosceles triangle. Doesn't look like it, but it is a right isosceles. Actually, well, that would be the 90 degrees. So this is also known as the 45, 45, 90 right triangle. Now, AB is 2 centimeters. Times that BC is also equal to 2 centimeters. M is the midpoint of BC, so each of these would be equal to 1. And C is the midpoint of AD. Now, what's the area in square centimeters of triangle CDM? So from this information, you can figure out the hypotenuse here. So this is a 45, 45, 90 right triangle. So when you have a 45, 45, 90, the sides are in a ratio of x root 2. So the side is 2. The hypotenuse would be x root 2 or 2 root 2. And since C is the midpoint, CD is also equal to 2 root 2. So from here, you can work to solve for some of the other sides. Now you want the area of triangle CDM. Now to find the area of a triangle, it's going to be 1/2 base times height, but the base must be perpendicular to the height. So if we use the base as this 2 root 2, then the height must be perpendicular to this base. So because this is an obtuse triangle, we're going to have to extend the base over to this piece here. And we need to find this height. And fortunately, this smaller triangle is another right triangle. Specifically, it's another 45, 45, 90 with a hypotenuse equal to 1. So in this 45, 45, 90 right triangle, this 1 corresponds to the x root 2 side. So if x root 2 is equal to 1, then x would be equal to 1 over root 2. And we can solve for this by rationalizing the denominator. When you have 1 over root 2, you can multiply by this form of 1, called root 2 over root 2, to rationalize the denominator so that the denominator becomes just root 2 times root 2, which is just 2, and the numerator is root 2. So this would be root 2 over 2 as the height. So for this triangle, the area would be the base and this external height. So the area would be 1/2 of the base, which is 2 root 2, times the height, which is root 2 over 2. So the 2's will cancel out with the 2. The root 2 and the root 2 would become just 2, and that would be 1/2 of 2, or just 1. The area is choice A, so you need to use the external height here. Okay, and here is the summary for this page. Okay, next for number 38, if you have a 1-inch thick stack of paper, has 200 sheets, a large thin piece of paper is folded in half, 2 thicknesses, then folded in half again, so it's 4, and so on. If Marge could fold this paper in half 35 times, how thick would this folded paper be? So here you have this 1-inch stack is 200 sheets. So one sheet, if you divide by 200, would be 1, again, if you divide by 200, would be 1 over 200 inches thick. So when you have 1 over 200, that's not a big number. But because you're folding in half 35 times, you're doubling this 35 times. So another way to express that would be exponent. So this would be 1 over 200 times 2 raised to the 35th power. So it starts out very thin, but after a while it gets pretty large because it keeps doubling. It's an exponential function. So the answer is going to be choice E. It's going to be way more than 10 miles. When you do 2 raised to the 35th power, the calculator can't even handle that. So it's beyond what a lot of the calculators can actually handle. So that's going to be a very long distance, even though it's in inches. Even if you divide it by 5,180 and divide it by 12, you're still gonna end up with a really big number because of this 35th power. It's an exponential function. Next, for number 39, the sides of the smaller regular hexagon lie on the diagonals of the larger regular hexagon. What's the ratio of the area of the larger hexagon to the area of the smaller hexagon? So for this hexagon, you can split this up into a bunch of triangles, specifically equilateral triangles, 6 equilateral triangles to be exact. So if you just pretend each of these equilateral triangles has an area of 1, the smaller hexagon would have an area of 6. Now for this larger hexagon, you want to kind of expand this outward. Now for the larger hexagon, you can actually cut that larger hexagon into 6 larger equilateral triangles as well. And when you do so, you can actually see that there's a very nice symmetry going on here. If you just take a look at one of those pieces, you've cut this triangle into half, and you made a whole bunch of smaller half equilateral triangles. Specifically, you have this piece and this piece, which would be the 2 halves of the equilateral triangle, as well as these 2 pieces, which are the other 2 halves, and these 2, which will make up another one of those equilateral triangles. So each of these larger triangles has an area of 3. So the entire thing will have an area of 18. So the larger hexagon has an area of 18. So the ratio would just be 18 to 6 or 3 to 1, which is choice E. So this is a really easy symmetry that you can take advantage of for these hexagons. Regular hexagons, anyway. Okay, next for number 40, a teacher asked Garfield to calculate 5 10-digit perfect square numbers. After a lot of arithmetic, Garfield turned in a list of the 5 numbers see below, but he made 2 mistakes. First, he spilled milk onto paper, so the middle 6 digits were impossible to read, and he made an error in calculating one of the 5 numbers, and that the number is not actually a perfect square. Don't cry over spilled milk, but determine which of these 5 10-digit numbers is not a perfect square. So when you have perfect squares, it's really helpful to look at the ones place, because when you're multiplying a lot of numbers, for example, like 111 times 111, you keep adding placeholder zeros when you shift numbers over, so that the ones place in the final answer is always going to be equal to the ones place of the numbers that you multiplied. So if you do that to the digits of the perfect squares, you have 0 squared, or you can actually start with 1 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and even if you try 11 squared, you'll see that the perfect squares, or the diagonals on the times table, there is a pattern there. The ones digit can only be on this list. So it could be 0, 1, 5, 9, 4, or 6. And here you see that one of these, choice C, is not going to be a perfect square. There's no way that a perfect square can end with a 2 at the end. So there's no way that this could be a perfect square because of this 2. All the other choices could potentially be valid. This 2 could be that incorrect one. Okay, and here is a summary for this last page. All right, thank you everyone for joining me today. Enjoy the rest of your day, and I'll talk to you guys in the next one. All right, bye everyone.